Good morning. I am Dr. Bindhu, Assistant Professor, Department of Science and Humanity, Emmanuel Arasar JJ College of Engineering, Nattalam. I will going to talk about universe discourse. The domain of a predicate variable is the set of all possible values that may be substituted in place of the variable. The statement x less than 5 can be denoted by p of x. Then p of x is a statement. Then statement condition is x less than 5. Then p is predicate is less than 5 and x is the variable. When a particular value is assigned to x, p of x is a proposition and has a truth value. Then example, p of 2, then p is a predicate, then p of 2, then a variable is 2. Then condition x less than 5, then x value is 2. And 2 less than 5, then 2 less than 5 is a this is a true condition. 5 is a greater value than which is a true statement. The next example is p of 6, then x variable is 6, then condition 6 less than 5, then greater value is a 6, condition greater value is 5, then it is a false statement. The statement x minus y equal to 1 can be denoted by p of x comma y, where p is the predicate and x, y are the variables. When particular values are assigned to x and y, then p of x comma y is a proposition and has a truth value. There is another way to get propositions or statements from predicates, which is known as quantification. There are two types of quantifiers. Then one is universal quantifier, other one is existential quantifier. First, I will explain the universal quantifier. Let p of x be a proposition function with the universe A. Then A is a universal set. Then statement for every x belongs to A, p of x is true is the universal quantification of p of x. It is denoted by for all x for every, then symbol is a for all symbol, x belongs to A, then p of x or for all x p of x. This is a then applied to the universal quantifier statement. Then note the prices for every x, for all x, for each x have the same meaning. Then it is denoted by same operator for all x. Then next one, then for all x, p of x has a truth value and it is assigned as below. Then for all x, p of x is a truth values true and false. Then for all x, p of x is true if it is true for every x belongs to A. Then for all x, p of x is false. Then if and only if p of x is false for at least one x in A. Example, let p of x be the statement x less than 5. What is the truth value of the quantification for all x p of x? Why the universe discourse is R. Then R is a real numbers. Then solution, clearly p of x is not true for all x. Then one real number taken, one real number 2. Then 2 less than 5. Then the statement is a true. Then 6, then take the x value is 6 less than 5, then statement is a false. Then above the values of 6, then all the values not true for the condition. Since condition, therefore then for all x p of x is false. Some more elements 0 to 0 to 4 numbers, then condition is true. Remaining all the numbers, this condition is a false. Therefore for all x p of x is false. Next quantifier is existential quantifier. Let p of x be a propositional function with the universe A if there exists an x in A such that p of x is true, then we can write it as there exists p of x, or there exists x belongs to A p of x. The quantifier there exists x, it is called the existential quantifier. It denotes the price there exists. The note, the prices, there is a x, there is some x, there is at least one x, they have the same meaning of there exists an x. Then it is denoted by, then the symbol is there exists x. An example, let p of x from x plus 2 less than 5. The existential quantification of p of x, there exists x, p of x is true. Statement, since p of 2 from 2 plus 2 less than 5 is a true statement. Then some elements, the statement is true, then more elements, then condition is a false. So then apply to the quantifier there exists x. Free and bound variables. Given a formula containing a part of the form x p of x, or there exists x p of x, such a part is called an x bound part of the formula. Any occurrence of x in an x bound part of a formula is called a bound occurrence of x, while any occurrence of x or any other variable that is not a bound occurrence, it is called the free occurrence. Further, the formula p of x either in x p of x or in there exists x p of x is described as the scope of the quantifier. Then example, x p of x comma y, then p of x comma y is the scope of the quantifier. Then all occurrence of x are bound occurrences, and then remaining occurrence y is a free occurrence. Then x is bound occurrence and y is a free occurrence. Then x p of x to q of x. Then scope of universal quantifier p of x to q of x. Then the all occurrence x is a bound. Then x p of x2, there exists y r of x comma y. The scope of x is p of x2, there exists y r of x comma y, while the scope of there exists y is r of x comma y. Then x and y occurrences are bound occurrences. An example, give the symbolic form of some men or gains. Then solution, then word some men or gains. Then first, then take the statement, denote the statement m of x, then x is a variable, then this sentence men gained, then different type of persons. Then first take x is a man and this g of x, then x is a gained. Then symbolic form is then some men, then some, it is used to the quantifier there exists x, then some men or gains, then m of x and g of x. It is a symbolic form of some men or gains. Next, other example, give the symbolic form of all cats have tails and no cats have tail. Then first take the statement, then C of X, then only one animals are given there, cat, then C of X, X is a cat, then other thing is tail, then T of X, X has a tail. Then symbolic form of one is then all cats, then it is used to the quantifier for all x, then C of x, then cat have tails, then C of x to T of x. Then symbolic form of other statement is no cats have tail, then no cats, then C of x to no tail, then negation T of x. That is a negation symbolic form of second statement. Negate the statement, every student in this class is intelligent in two different ways. Then statement is every student in this class is intelligent in two different ways. Form 1, there is a student in this class who is not intelligent. Then form 2, it is not the case that every student in this class intelligent. The next example, find the truth value of for all x square less than greater than or equal to x if the universe of discourse consists of all real numbers, or also write the negation of the given statement. Then solution, the truth value of the given statement is false. Then x square greater than or equal to x. Then for example, then x, take the value, x is 0.5, then x square equal to 0.25, then less than 0.5. This statement is a false. Then negation of the given statement is if the negation for all x negate the statement, negation for all x square greater than or equal to x, that is equal to, then for all is the negation applied to the quantifier, then for all is changed to their h states, the negation of x square greater than or equal to x, that is equal to their h states, the negation is a condition is not true, then x square greater than or equal to x is a not true, then false condition is x square less than x. It is a negation form of the given statement. The next, inference theory for predicate calculus. In addition to roots of inference for propositions, we shall now consider some important roots of inference for quantified statements. During the course of derivation, it may be necessary to eliminate the quantifiers. This is done by rules of specification US and ES. Once the quantifiers are eliminated, we proceed as in propositional calculus to reach the conclusion. Sometimes we may require to reach the conclusion in quantified form. This is done by the rules of generalization UG and EG. Rule US, the universal specification. US is full form is universal specification is the rule of inference which says that we can conclude PC is true for an arbitrary element C of the universe of discourse. If for all x P of x is true, then for all x P of x is a true, then the statement we can write P of C for some C. This is a universal specification rule. The next rule is ES. ES full form is existential specification. Then existential specification is the rule of inference which says that there is an element C in the universe of discourse for which PC is true if there exists x P of x is true. Then there exists P of x is, we can write P of C, then for particular C, then quantifier is there exist, then write the statement for particular C. It is a existential specification. Next rule is UG, then universal generalization. Then universal generalization is the rule of inference which says that for all x P of x is true if P of C is true for any arbitrary element C of the universe discourse. Then P of C2 for all x, then take the element P of C, then take the element is C, then implies for all x P of x for an arbitrary element in C. Next rule is EG rules, existential generalization. This existential generalization is the rule of inference which says that for a particular element C of the universe of discourse, if P of C is true, then there exists x P of x is true. Then P of C is the particular element, then implies, then there exists it is used to the quantifier, there exists x P of x for some C. Prove that for all x P of x to Q of x, then for all x R of x to negation Q of x, then implies for all x R of x to negation P of x. Then solution, then statement for all x P of x to Q of x, then apply to the rule P. P means predicate rule. Then next rule for universal specification, then for all x is given there, so apply to the universal specification. Then for every element, then taken C, then P of C to Q of C. Then next line we have to apply the predicate condition, then for all x R of x to Q of x, then for all it is used to the universal quantifier, then universal specification R of C2, there exists Q of C, then rule T, then contrapositive condition, then negation Q of C, then rule negation Q of C2, negation P of C. Then the hypothetical conditions R of C2, negation P of C. Therefore then universal generalization condition is for all x R of x to negation P of x. Then use direct method to prove that the conclusion there exists x Q of z follows from the premises for all x P of x to Q of x and there exists y P of y. Then by using the indirect method we take negation there exists z Q of z as additional premises, then there is negation of there exists z Q of z then additional premises, then apply to the negation, then second row, then apply to the De Morgan's law, then for their exist is changed to for all z, negation q of z. Next we have to apply the universal specification in second row, the negation q of a. The statement, then premises for all x p of x to q of x. Then next line, when we have applied to the universal specification p of a to q of a, then the next premises, there exists y, p of y. Then next existential specification is applied to the there exists y, then existential quantifier, then existential specification, then p of a. Then next, then 7 and 5th row, then apply to the modus ponens, then modus ponens condition, then q of a, then p of a to q of a and p of a, then answer is q of a. Then the conjunction of 8th row and third row value is negation q of a, 8th row value is a q of a, then take the conjunction q of a and negation q of a, then q of a and negation q of a value is a false, then false is a contradiction. Then use indirect method of proof to prove that for all x p of x and r q of x, then implies for all x p of x r there exists x q of x. Then using the indirect method, first then the premises value, then take the negation, additional premises, then take the negation of for all x p of x r there exists x q of x. Then rule, then first row, then apply to the De Morgan's law, the negation of first term and negation of second term. Then the third row is a simplification, is a negation of for all x p of x. Then next fourth row is a simplification in second row, there exists negation, there exists x q of x. Then fifth row value is same, then the condition third row, then for negation of for all x p of x is equivalent to there exists x negation p of x, then apply, then the right there exists x negation p of x. Then fourth row, then we can apply to the condition negation there exists x p of x is equivalent to for all x negation p of x, then for all x negation q of x. Then next, then apply to the existential specification in row 5, then negation p of a. Then next universal specification in apply to the row 6th row, then negation q of a. Then next write the premises value, then the statement for all x p of x or q of x. Then 9th row, then we can apply to the condition universal specification p of a or q of a. Then 10th and 7th row values, then apply to the disjunctive form, then 7th row value negation p of a, 10th row value p of a or q of a, then answer is q of a. Then 11th and 8th row is applied to the conjunction form q of a and negation q of a, then answer is false, that is a contradiction. Then establish the validity of the following argument: all men are mortal, Socrates is a man, therefore a Socrates is a mortal. Then solution, then first take the two statement, then h of x from x is a man, then m of x from x is a mortal. Then the write the premises are, then x, H of H2 Emma. All men are mortal. Then all men, all is for all X. Men is H of X. Then men are mortal. Then mortal is M of X. H of X2 M of X. Then the specification, then form is H of S implies M of S. Then first one, then the premises, write the premises for all X, H of X to M of X, then apply to the universal specification H of S to M of S, then write the specification premises H of S, then the second and third row apply to the modus ponens condition H of S to M of S and H of S. Then answer is M of X. Thus the given argument is a valid argument. Then use of rule of inference to prove that the premises a student in this class has not read the book and everyone in this class passed the first exam imply the conclusion someone who passed the first exam has not read the book. Then this three types of locations, then the classroom, read the book and passed the exam. Then first take C of X from X is in this class, then B of X from X has read the book, then P of X from X passed the exam. Then the write the premises are there exists X, then a student in this class has not read the book, then there exists X, C of X and negation B of X, not read the book, then read the book is B of X, then not read the book is negation B of X. The next sentence, everyone in this class passed the first exam. Then everyone, then they used the quantifier for X, then class C of X, class is C of X to passed the first exam, then P of X, C of X to P of X. Then implies, then conclusion, someone have passed the first exam has not read the book, then passed the first exam, the someone, then used the quantifier there exists X, that the passed the first exam is P of X and has not read the book, then negation B of X. Then first step, then first write the first premises, there exists X, C of X and negation B of X, then apply to the existential specification C of A and negation B of A, then simplification method, then apply to the second row, then answer is C of A, then next apply to the simplification condition second row, then answer is negation B of A. Next we have to write the premises value for all X, C of X to P of X, then for all is a universal quantifier, then apply to the condition universal specification C of A to P of A, then the condition for modus ponens condition in third and sixth row, then third row is C of A, sixth row is C of A to P of A, then answer is P of A. Then our conjunction condition is applied to the seventh and fourth row negation B of A, seventh row P of A, then conjunction value P of A and negation B of A, then existential generalization condition in eighth row, there exists X, P of X and negation B of X. Thank you.